Hello everyone. In today's sessions, we will discuss intermediate shafts. So this is the example of intermediate shafts. Intermediate shaft means a shaft which will consist of more than two members. Then that shaft is called as intermediate shaft. Okay. If we look at this arrangement, we have shaft AB, shaft BC, and CD, which are connected to each other, and these shafts are fixed at location A and D. We have to find out torque at point B, torque at point C. Now B is the common junction for shaft AB and shaft BC, whereas C is the common junction for shaft BC and shaft CD. So what will be the torque at point B? We have discussed that if you look at the observer position from this side, this curl finger will indicate the direction of rotation. Okay, and thumb is towards the shaft. We apply this right hand thumb rule. Then this torque is, if thumb is towards the shaft, then this direction is called as clockwise direction, and then that torque is nothing but negative torque. If you consider anti-clockwise direction of rotation of a torque from this side, observer is looking from this side, then thumb is away from the shaft, so that torque will be a positive torque. So at TB, what we have? We have minus T1 plus T2. Okay, so torque at 1, that is torque at shaft 1 will be TB plus T2. Similarly, torque at C will be again, it is minus T2 minus TC is equal to minus T2 plus T3. So what we have? We have torque at shaft 3, T2 minus TC. So total angle of twist is addition of all this, because these are the intermediate shaft. So we have to consider, if we want to calculate angle of twist, then we have to add all the angle of twist for shaft 1, shaft 2, shaft 3. So we have total angle of twist for intermediate shaft theta 1 plus theta 2 plus theta 3 is equal to 0. Okay. And what is our theta? It is TL upon GJ. Okay. So TL upon GJ for shaft 1 plus TL upon GJ for shaft 2 plus TL upon GJ for shaft 3. So these are the equations which I have to use while calculating angle of twist and torque for intermediate shaft. Now we'll take one example and we'll discuss how to calculate that theta value and torque value for intermediate shaft. Okay. So we have shaft AB with a diameter of 40 mm, subjected to clockwise torque of 100 Newton meter at point C. We have to find out reactive torque at support, find the maximum shear stress at AC and CB, and find the angle of twist at 2 meter from B. And they have given G value 80 GPa. Okay. So first we have to find out polar moment of inertia for this shaft. So polar moment of inertia is pi by 32 d raised to 4. Diameter is given. So what is the value of diameter? It is 40. So J value is pi by 32 into 40 raised to 4. That is 251.33 into 10 raised to 3 mm raised to 4. Now, if you consider this intermediate shaft, theta at section AC is equal to theta at section CB. So what is theta? Theta is TL upon GJ. So we have to calculate correlation between torque for section AB, AC, and torque of section CB. Okay. So we can take torque at A by taking GJ for same, that is torsional rigidity, and that J value is same. It is uniformly made up of a diameter of 40 mm. So that J part will get cancelled, G also will get cancelled. So what we have? We have correlation in terms of length. So we can write torque at A into length of that section AC, 2.5 meter, equal to torque at section B into length of that section B, 4 meter. So we have that relation, torque at A is equal to 1.6 times torque at B. Okay. So we can write total torque is nothing but addition of torque at A plus torque at B. So total torque they have defined, which is 100 Newton meter, that is given at point C. So you can write 100 equal to 1.6 TB plus TB. You have put up that value of TA in terms of TB. So what we have, TA is equal to 1.6 times TB. Okay. So if you put that value of TB, then you will get value of torque at point B. So that torque at B is 38.46 Newton meter. And we have calculated that correlation between torque at A and torque at B. So torque at A is equal to 1.6 times torque at B. So you can put that value of torque at B, that is 1.6 into 38.46. So we have torque at A point is 61.54 Newton meter. So in this way, we can calculate torque at A and torque at B. Okay. Now next part is we have to find out maximum shear stress at intersection. So to calculate maximum shear stress, so to calculate maximum shear stress, we have to consider the area at which there is a maximum torque. So what we have at A, this section AC is taking torque of 61.54, whereas section CB is taking torque of only 38.46. Because the correlation between torque and tau is that shear stress is directly proportional to torque. Okay, so you have to remember this part. Whenever torque is more at particular location, that torque we have to consider while calculating shear stress. Okay, so you can put that value. Maximum shear stress we can write tau by R is equal to torque upon J, that is polar momentum in inertia. So what we have, radius diameter is given 40, so radius is 20 mm. So you can write tau upon 20 equal to torque, maximum torque we can take 61.54. Now it is in Newton meter. So we have to consider that value in Newton mm. So you can write 61.54 into 10 raised to 3 Newton mm upon J value. So it is J 5 by 32 into 40 raised to 4. That is 251.33 into 10 raised to 3. So you get that tau value 4.897 Newton per mm square. Okay. So we have calculated that maximum shear stress in part AC and CB. So we have maximum shear stress at AC because torque is more at section AC. That's why we can write maximum torque will occur at section AC. Now next part they have asked to calculate angle of twist at 2 meter from B. Okay. So from B we have to find out angle of twist at 2 meter distance. So that we can take that length 2 meter. G value is available. G value is given 80 GPa theta, that is you have to find out that theta value. Torque at B is 38.46 into 10 raised to 3 and J is 251.33 into 10 raised to 3. So if you put all these values, then you get theta 3.8256 into 10 raised to 3 radian. Okay. So in this way, we can calculate maximum shear stress, then torque at support, maximum shear stress at section AC, and angle of twist at length of 2 meter from point B. Okay. So this is all about the calculations of torque, shear stress, and angle of twist. Thank you all.